I wanted to introduce a small feature in EnergyPLAN, which is very useful when you want to approach a certain result and you don't want to manually do so many steps of calculation, look at the results, etc. And this feature would allow you to give a range of for wind power development, for example. So when your aim is to achieve this net import-export balance 0, then you would, what we have done now, enter a wind power capacity, look at the results, enter it again, etc. So which is of course time consuming, and of course after a few steps you will find your results somehow. But there is a quicker way which also can be used in other cases. Let's have a look at that. And that feature you will find under output as well. When you just click on output, you will get this screen which is up now. And this gives you the opportunity to do what EnergyPLAN calls run serial calculations to the clipboard. When you click at define input and at this button a few times, you will see input is RES, renewable energy source number 1, which we have defined now as our wind. So when you just click on this variable renewable electricity where you have entered the wind power, so this is like RES number 1, that would be wind. And go back to the output, this is RES number 1, wind. When you click a second time, it would be photovoltaic, which is in the list on the second place. But let's go back to RES number 1. You have 7 options here. And what we can do now, we can actually enter 10 data or 11 data points as the input value for this wind power capacity. And we can start with 0 or whatever where we want to start, and have several steps. In this case, in which I have prepared, is like 3 megawatt steps. That would be a 3 megawatt turbine. Can be a smaller turbine or a bigger turbine. So that means no turbine at all, 1 turbine, 2 turbines, 3 turbines, etc. So when you enter data like this, you will go up from 0 to 30,000, like 10 turbines in your community. And when you now would start the calculations, it wouldn't do anything because it's still off, this feature. You have to switch on the feature. Yeah. And then when you start the calculations, it will not give you the entire set of results for this 11 options, 10 or 11 options, it's 11. But it gives you only a selected, very small selected number of results. And this you can choose here, define output. And here, for example, we could define, we want to see how much we still import when we go ahead with this set of, or this series of wind power installations. So what do we get now when we click on clipboard? We get now, I have clicked now on this button and the calculation is already completed. It has done 10 calculations in a row. And in our clipboard we have now the result of all the import data. Yeah? So, and we want to paste it into Excel, for example. As our first approach, we tried to install only wind, and we found that for our case with the 20 gigawatt hours, yeah, for our case with the 20 gigawatt hours electricity consumption, it would be a requirement between 6 and 9 megawatt of wind to balance the import-export balance over the year. Of course, we always see a lot of export and a lot of import, but still the balance would be close to 0. And then we tried now to find out, okay, when we don't have the option of wind, but we have the option of solar PV because we have a lot of unused land, like in some cases, or unproductive land. So the result is about 3 times the capacity of wind what we would need to install a solar PV. I think it's somewhere between 18 and 20 megawatt. And the reason, of course, is the capacity factor. We know that the capacity factor of solar is about 10, 11, 12%, and wind is 30%, which means in practice this difference, the factor 3, results into 3 times capacity of solar PV you would need to install to achieve actually the same result. Of course, the distribution over the year looks different because solar production is much more during the summer months, and the wind production is a bit more during the winter periods. The wind profile is a little bit less during summer, a bit higher during the winter periods, which is matching actually the consumption also better, which also results into a better import-export balance when you invest into this technology. But I think this was a nice exercise also to see, to when you get to learn this tool, focus only on one sector first, because otherwise you get so many results and they are overlapping and you don't know what's really happening. So when you go through, perhaps as you go home, go through some of the exercises which EnergyPLAN actually offers, and they actually do the same. Start off with just one sector, decide what demand you want to use, and then add different power production options, and then you see what's happening. And now we will have a quick look on the heating part. I think that's also important. And in EnergyPLAN, when you look at the demand side, there is this heating tab. The heating part is to be found under demand heating, at least the demand side. There are many other screens I think one would need to use when going into detail. But first step is always to find out how much heating demand we actually have in our community. And this screen is split in let's say two main sections. The middle part is like all individual heating, and with individual heating, EnergyPLAN means everything that is not connected to district heating. I think in many, like 99% of our Irish cases, we will have only individual heating and no district heating, unfortunately. But it's possible to, of course, to simulate and model it for a future scenario. If you think local district heating based on willow production and willow wood chips, which then would feed in, one could add this in a future scenario. But here again, we face the challenge, which input data do we add in here? And when you look at the screen in front of you, you have the first column, the fuels, and the first 4 rows here are the coal boilers and oil boilers and natural gas boilers and biomass boilers, all these boiler-based heating systems. And then the next 3 rows is micro CHP. I think we don't have it yet, really, as a technical option. It might be available, but it's not economically feasible at all. Micro CHP, which CHP is combined heat and power. That means a small gasifier, for example, of 10 kilowatt or so, which produces electricity and heat by gasifying pellets or wood chips. Or
can that be done from manure?
From manure?
Yes.
With anaerobic digestion.
Yeah. So you would probably produce biogas and then burn the biogas in an engine and produce electricity and heat through that. That's a possibility. Yeah. But the second last 2 rows is heat pump and electric heating. I think this is relevant for our cases. So the first 4 rows with the boilers, and the last 2 rows with heat pump and electric heating. And also here we have, of course, this distribution profiles, which we heard so often about. When you look at top at this button here, heat, and in my case, I don't know which files you have now. Here we should have this HDD files with HDD17HW. So if you have that, then you are on the right track, and that actually shows you how the heat demand is distributed over the year. And yeah, we have had a look before on that. We don't look it up. You know, it peaks, or the higher parts again in the winter months, and then it drops during the summer months. It drops down. It doesn't drop down to 0 because we have included the hot water demand, which is about 20% of the heating energy demand. So what do we have here?
Just confirm.
Yeah.
I probably said this before.
Now this temperature is taken from the MET data.
Yeah.
From the closest weather station. I didn't find an Athlone weather station, but the closest one, I don't remember the name, but it's only about 10 kilometers away.
From here.
Yeah,
So
from
it's
here.
taken from
So that's the local temperature. Yeah. So if you then later work on your local communities, we will have to download the data from MET for the temperature data for your location and then convert it into this HDD, which is more or less a simple exercise in Excel. So we can provide this for you, or you can have also the Excel file and do it yourself. As you're, I have seen many of you are very good in Excel, so it shouldn't be a problem too. And then you have to export it into a simple text format, but let's not go that path now. Okay, so we have all the HDD data, but we have now only these 4 or let's say 6 figures we need to enter for our 3,000 or how many households we have. So how do we get this data? So that's always a challenge again, because EnergyPLAN has this aggregated data, and we have yesterday seen as we created this reference energy system, some of you have done more or less an inventory of all the buildings, and of course much of the input data we create for EnergyPLAN or for any other model, we will do it in our spreadsheets in Excel or something similar, and then create the data we need to put in Excel. I don't know if Ola or Ashley, you have shared this Excel file which I have sent. The final one. I have added a few small things in the last one, but if you don't have the last one, it's also fine. So what I tried to build here is like more or less copying what we have in EnergyPLAN or what we need in EnergyPLAN. If you have this file open in front of you, like when you look at the right-hand part, the shares of heating technology. Yeah. So I also have entered district heating, of course, but even if I know there is no district heating, but it's there. And then we have these individual heating boilers, these first 4 rows in EnergyPLAN. When we look at the EnergyPLAN here, this first 4 rows, coal, oil, natural gas, and biomass. And then we have individual heating, the electric part, heat pumps and direct electric. So these are percentages which perhaps can help us to come to an assumption which is somehow reflecting reality. Of course, we know the building stock more or less, and I created 2 different building stock groups. One is everything what was built before 1990, which should have higher kilowatt hours per square meter and year, and then I created another group, everything what was built after 1990, and then of course we still could diversify a bit more, but for our exercise I think it's enough to have 2 only. Yeah? But if you have data, more exact data from your local GIS system or building database, then of course you can do that. And for now I have only created 4 building types: single-family homes, apartment buildings, commercial buildings, and public buildings. Commercial buildings and public buildings could be almost the same, but commercial buildings, you could mean office buildings or shopping malls, for example, and public buildings are like swimming halls or sport halls or churches or something like that. So, and then you can do your inventory and put in the data we have here. And we said we have, in our case, 3,000 people, about 1,000 households. And we could say how many are usually living in single-family homes and how many apartment buildings would you have in our example case. So give me some idea. Yeah. Like we have 1,000 households. How do we distribute it in single-family homes and apartment buildings? Where should the people live in our example community? 90% live in single-family homes. Yeah. So we will have about 900 households, single-family homes, and then we have apartment buildings. The rest of the people live in apartment buildings. We will have 10 apartment buildings, each having 10 flats. That means we have 100 flats. Then we have this 1,000 households. And each apartment building has about 1,200 square meters, but perhaps too much, 10 buildings, 10 flats with each 70 square meters or 80 square meters would give us 800 square meters in as an average size of one of the apartment buildings. Just an estimation, and of course you know your community better. Then we calculate automatically the total. And then, do we have any commercial buildings in our community? Is there a shopping mall or something like that? Yeah? Okay. One or two? Yeah? A mall? Yeah? One? Okay. It has a size of, I don't know, 1,500 square meters. Is perhaps too big. Let's say 400 square meters. Something like that. And then we have a public building, a school, for example, or an elderly home. Yeah, let's say 3 public buildings, and the square meter per public building is like 300. Okay, and then we have to figure out. Okay, and now we have entered all this in the part where I said, okay, these buildings are built before 1990, just as an example. We can also just abandon this other part and put zeros here everywhere, then it's not used at all. Yeah. But what is the average like kilowatt hour per square meter per year for the family homes?
For heating?
For heating, yeah. Like in our example village, yeah. So now we have done our inventory and energy inventory of the buildings. Because it's very rough estimates, and you would have to, of course, in your community, get the details. But I think we have an overall average of 99 kilowatt hours per square meter per year now for all our buildings. A total energy consumption of 11.57 gigawatt hours per year for all the buildings. And now we have to figure out how do we heat our buildings. We have no district heating at all for now. We put zeros percentage here. So now we try to figure out what percentage of different heating types we have in our buildings. How are our single family homes heated? So we have now 100% for the single family homes, 30% coal or peat, 60% oil, and 5% biomass. 1% heat pumps and 4% direct electric heating. Next, apartment buildings. How are apartment buildings heated? And how do we heat our commercial buildings? We said there's one shopping mall or something like that. Is that going in the right direction? 50% oil for commercial buildings and 20% heat pump, because they have this AC system, air conditioning systems, and about 30% direct electric heating. And finally, we have the public buildings, like a school or an elderly home or something like that. Okay, let's put 50% oil and 50% direct electric heating for now. Yeah, and then see how we continue from here. So we have entered now all the data in buildings built before 1990. It doesn't matter. Yeah? We have tried to find out the averages, which averages all our building stock. And I hope my worksheet functions as expected. Don't get hooked up with the percentages. I don't think we will find the right figures right now, but at least you know how to think about it when you're going into the details in your community. Yeah? We have to get this let's say 6 figures. So how much of the building stock is heated with coal or peat, and how much with oil and natural gas and biomass, and then the second part, the electric, is split in 2, heat pumps and direct electric heating. So these 6 figures we have to somehow figure out from our inventory of the building stock.
Just a question about that.
So this little spreadsheet which I've created will help you to go to the next step to find out which figures actually to enter into EnergyPLAN when you have done your exercise on finding out what percentage is actually used in the different parts of the building stock. Then when you scroll down in this Excel sheet, you will find the energy demand now per of these 6 figures we want to enter for the different buildings calculated from the percentages above and from the kilowatt hours per square meter and so on. And when you scroll down at the bottom, you will then find, I think in this row number 43, there are the figures which we would need to enter into EnergyPLAN to reflect the energy consumption for heating for the building stock. So of course your inventory can be much more complicated, but at the end we need to have these 6 figures to enter into EnergyPLAN.